An important thing to remember about virtual LANs is that they require switches to operate. Bridges and routers are just not able to provide the capability required to form a VLAN. And if you think back a little to how bridges and routers work, this may become obvious. Bridges can only control traffic based on a Layer 2 address, and routers can only control traffic based on a Layer 3 address. So what does a switch have that's different? The switch has more intelligence, and just like people, the smarter you are, the farther you can go, and the more you can do. Switches have the ability to make forwarding decisions based on many parameters, and since each switch port is independent from the others, you're able to virtually group any devices to form a virtual LAN. Another amazing thing about switches and VLANs is that the virtual LAN you create is not specific to a single switch. This means you can have several switches in a network, and several ports on each switch can be grouped to form a large VLAN across the network. In fact, a VLAN can even extend across a WAN. For example, you can have several ports on a switch in Philadelphia and several ports on a switch in Tokyo virtually grouped together to form a VLAN. This example is just one of an almost infinite number of scenarios that are made possible using VLANs. So let's see how VLANs really work. A switch supporting VLAN capabilities is configured to look for some type of specific information. This information might include a specific application an end user is running, a special type of protocol, or even traffic from a specific port. When a switch receives a packet of data meeting the search requirements, the station that generated the packet is added to the virtual LAN, joining every other station transmitting similar information. There are really only 3 steps to creating a VLAN. First, the network manager configures the switch with what to look for. Second, the switch detects matching traffic. And third, the switch identifies the station that sent the matching traffic and adds that station to the VLAN. As you can see in this diagram, I've created 3 VLANs. Each has its own dedicated server. If a station, no matter where it's located, matches the VLAN parameters, it's added to the VLAN and has direct connectivity to all other stations on the same VLAN. Now, it's important to note that communication between devices on the same VLAN is supported by bridging, while communication between devices on different VLANs requires routers. Routers separate VLANs just like they separate networks. This diagram shows a physical view of a network constructed using VLANs. This physical view illustrates how the network is actually organized.